So this first lesson and what we learned about what you did in that exploration yesterday is quadratic functions in vertex form. So the first question that we need to answer is, what is a quadratic function? Who can answer that? So quadratic function, there's actually two things that make it quadratic. The equation has a degree of 2, so that's the x squared. If it has that x squared, then that's a degree of 2, and it's quadratic. It can't have any power bigger than a squared, so it couldn't have an x cubed and an x squared. It wouldn't be quadratic anymore. X squared has to be the largest power of x for it to be quadratic. And the other thing that defines it is the shape of the graph. It's shaped like a parabola. And a parabola is that shape, kind of like a U shape. Those are the things that define a quadratic function. When we talk about quadratic function in vertex form, we're talking about specifically an equation that looks like this. Y equals a x minus p squared plus q. That's vertex form. A, p, and q could be any real numbers. So sometimes it'll be y equals 2, x minus 4 squared plus 1. Or it could be y equals 1/2 x plus 6 squared minus 3. Or whatever. Those a, p, and q could be any real numbers. But it has to be in that form when we're talking about vertex form. So you might remember when you learned about linear functions, you might have looked at them in slope-intercept form and standard form and point-slope form. This is the same kind of idea as that. And just a couple of things here. We say all parabolas can be thought of as transformations of y equals x squared. So yesterday we started out with that y equals x squared, looking at that. And then looking at when we change the parameters, which are the a, p, and q, in the equation, how does that change the graph? So we're transforming y equals x squared by putting different numbers in there, changing the parameters. That's how we change the graph. What we're going to do next is just look at each parameter separately and see what it does to the graph. And we already talked about it briefly, but I just want to make sure you have kind of all the notes together in one place and a full explanation. So first we're going to talk about the a parameter, which means in that y equals a x minus p squared plus q, it's the number in front of the x. It's usually outside a bracket unless p is 0. So sometimes you'll see an equation that just looks like y equals a x squared, or sometimes it'll be the x is in brackets with a p value. But that a parameter. And I have a couple of different graphs here where I changed the a parameter. If you look, the red graph is just y equals x squared. And here I've changed them. In this one, the a value is positive. In this second one, the a value is negative. So here's the kind of note, the information that you need. If a is greater than 0, the graph opens, what are we going to write in there? Up. And if a is less than 0, so a negative number, the graph opens down. What if a was equal to 0? I didn't have anything in there about that. Anybody have an idea? If a is equal to 0, it's actually not a parabola at all. So it might be linear, or yeah, I guess it would be linear. So that's the first thing that most people had already figured out. If it's a positive number in front, it opens up. If it's negative, it opens down. Here's the other part that I just talked about really briefly. If a is greater than 1 or less than negative 1. So that's this one. Here a is 2. That's greater than 1. Or if it was negative 2, it would be less than negative 1. So if you kind of think about a number line of your a values, it's all those numbers that are greater than 1 or less than negative 1. So that part of the number line. The graph is, and in here I want to write either narrow or wide. the graph is narrow. And when I say narrow, I mean narrow compared to y equals x squared. If this little notation here means if a is between -1 and 1. So that would be something like 1/2 or 1/4 or -0.2, those kind of numbers. The graph is going to be wide. And again, wide compared to y equals x squared. So it's going to make it wider. See how this green one is wider than the red? Because it has an a value that's between -1 and 1. It's -0.5. That's the a parameter done. The next one that we're going to is p. That's the next one that comes up in the equation. So the p, that's the number that's subtracted from x. So if you remember, I don't know why that's not working. Y equals a x minus p squared plus q. We're talking about this p that's subtracted from the x. And I think we came up with it earlier, but you can see some examples here as well. Here the p-value, this is y equals x plus 5. This is y equals x minus 3. We need to think about what's the p-value. And this is a little bit tricky and confusing because it's x minus p. If we have x minus 3, what's p equal to? 3. That's not bad. Okay, p equals 3. If we have y equals x plus 5, which is what this one is, what's p equal to? -5, right. Because we're not looking at what value is added to the x, we're looking at what value is subtracted from the x. And here we have 3 subtracted from the x. If this says x plus 5, -5 is what's subtracted from the x. So it's the same as if we wrote x minus -5. That's the same as x plus 5. So the p-value is -5 here, and the p-value is 3 here, and I want you to remember that when we go to answer these questions, because the question, this one where p was -5, what happened to the graph? It was translated to the left. And here, when p was equal to 3, it was translated 3 units to the right. So it says if p is less than 0, the graph is, we're going to say translated p units. So whatever p is equal to, it's that many units. And then I want to say to the right or to the left. So when p is less than 0, that's this one, it goes to the left. And I guess we'll say for this one, if p is greater than 0, the graph is translated p units to the right. So we did A and P, so I guess we just need to look at Q. Here we go, Q. The Q parameter. So Q is that number that's added or subtracted at the end. Remember again, y equals a x minus p squared plus q is the equation in vertex form. So what we're looking at is that number at the end that's added. So here, this blue graph in the first one is x squared plus 4, and the purple one here is x squared minus 6. If q is greater than 0, what happens to the graph? If q is greater than 0, the graph is translated up q units. So whatever number that is, that's how many units it's moved up. If q is less than 0, the graph is translated down q units. the next thing that I want you to think about is, in terms of this y equals ax minus p squared plus q, what are the coordinates of the vertex? You already know, what is it?
P and Q.
P and Q, right. Because P tells you how far to the right or left it moves. Q tells you how far up or down it moves. Because the vertex starts out at 0, 0, P and Q will be the vertex. So that's the last thing that I wanted to mention along with this one, is that the vertex, now that we know about P and Q, is at PQ. And now we'll have a look. If this is the equation, y equals ax minus p squared plus q, determine the vertex. We said that that vertex is going to be at P and Q. So for the examples that are there, y equals negative 3, x minus 1 squared minus 4, can you tell me where the vertex of that parabola would be? 1, negative 4, right. What's going on here? Oops. And for this one, y equals 0.3 x plus 2 squared minus 1.
Negative 2 or negative 1.
Negative 2, negative 1. So you'll notice, because it's x minus p, we're switching the sign of p, right? You're looking at what number is being subtracted. Positive 1 is being subtracted here, negative 2 is being subtracted here. You can just think of it, like, to simplify it, as you have to switch that sign. And switch that sign, but this one stays the same, the q value. Knowing all that, if I give you an equation like this one, y equals negative 3x minus 1 squared minus 4, you should be able to get a pretty good visual of what that function is going to look like. Maybe you could make an exact graph, but even if we're just thinking roughly what does it look like, well, now we know that the vertex is at 1, negative 4. So say something like that. We also know that it opens down, and we know that compared to y equals x squared, it's narrow. So I can get kind of an idea of what the graph looks like. It's definitely not perfect. I'm not doing it on graph paper. My pen slipped a little bit, so I have a funny wiggle in there. But you get kind of a visual of what it looks like. Without ever having to use your calculator or make a table of values or anything, you can get a lot of information about that quadratic.